Good evening, sir. HOD sir, good evening.
Good evening. Good evening.
Sir, we will start in 2 minutes.
Yeah, sure.
Yes.
सर है अभी जस्ट मैंने किया सर वो आप करना है सर मुझे करना है कि पूछ लो एक बार पूछ किसे करना है पूछने वाले सबको बोलेंगे वो आपको बोलेंगे अच्छा ठीक ओके जस्ट फॉलो ओके
So now can we start?
Yes, you can start.
Yeah. Hello and good evening, everyone. My name is Ashant Rahul, and I'm serving as a president of IIT Student Chapter Roorkee. It is my privilege to extend a warm welcome to all esteemed professors, distinguished dignitaries, and all my dear friends. On behalf of Indian Geotechnical Society, Student Chapter Roorkee, in association with Department of Civil Engineering, IIT Roorkee, I am delighted to welcome to you all in this special lecture series under the online lecture series Earth Engage, Bridging the Gap Between Academia and Industry. The objective of this lecture series is to bridge the gap between academic knowledge and the industrial applications and to inspire the participants to become well-rounded engineers with a strong practical understanding of geotechnical engineering. This lecture series comprises insightful lecture delivered by renowned industrial experts. For our inaugural session, we have honored to have Dr. Ratnakar Mahajan, Regional Technical Manager at Maccaferri Environment Solution Private Limited, is today with us. I am very much thankful to Dr. Mahajan for accepting our request. Now I'd like to call Professor Praveen Kumar, sir, HOD of Civil Engineering Department, to say a few words. Sir, please.
Thank you. I also welcome Dr. Ratnakar Mahajan, who has accepted to give this lecture, and all the persons who have joined from other colleges, other institutes, other IITs, they are also welcome. My colleagues from IIT Roorkee Civil Department. So it's always and a very appreciating thing that our IGS group is organizing almost on every 15 days. They are having one lecture, and I always say that within the department and outside the department, they have a very good bonding. So I'm sure that Dr. Mahajan, Dr. Ratnakar Mahajan, is also part of this geotechnical group, which is working throughout the country, whether they are the academicians or whether they are the field persons. With the help of each other, they are holding the flag of geotechnical engineering or in general civil engineering. That's to be appreciated. So again, I welcome Dr. Ratnakar Mahajan here in department. It could have been better if you were with us at the department. But anyway, the next time we will call you to be with us in person to meet us, to give your lecture to our students. So thank you and welcome.
Thank you, sir, for your words. Now I would look to call Professor Vishwas Sawan to say a few words regarding this lecture series.
hello good evening everyone for the speakers from the India. Okay, it may be good morning from the international audience. Okay. So first of all, I welcome you all for joining this expert series arranged by IIT Turkey chapter and Department of Civil Engineering. So we have invited experts from the industries and academia, particularly Dr. Ratnakar Mahajan, Dr. Sebastian Logo, Dr. Jaykumar Shukla, Dr. Jian Long from Fugro, then Ms. Shalu Puri and Neeraj Kumar Das. So our intention is these experts will share their wisdom and knowledge about the fields and practices. Many times we have a doubt about choosing different design parameter, particularly when you consider about the geotechnical design. Okay, but let these experts will guide on this, and maybe they can also share the challenges in their experience while designing or tackling a particular problem and how they overcome them. Okay. So with these few words, I welcome again all of you, and I invite again thankful to our today's speaker, Dr. Ratnakar Mahajan, for accepting our invitation. So it's over to you, Sujant.
Thank you, sir, for your words. Now I'll call Professor Kaustubh Chatterjee, sir, to introduce our speaker.
Okay. So it gives me immense pleasure to introduce our today's speaker, Dr. Ratnakar Mahajan, who is working as a regional technical manager at Maccaferri, responsible for India, Southeast Asia, and the Pacific market. Civil engineering having a key experience in the field of soil reinforcement, geotechnical, centrifuge modeling, instrumentation, earthquake analysis, ground improvement, retaining structure, stability, river training, and rockfall protection, and various allied fields in the fields of geotechnical engineering. He was instrumental in the development of new connector for reinforced soil walls and take care of various research and development activities. He's also an alumnus of IIT Bombay with Professor BBS Wilkham and an university rank holder graduation. He's associated with numerous prestigious projects related to infrastructures in India and all that. Dr. Mahajan has contributed to various codal guidelines for the Bureau of Indian Standards, that is BIS, Indian Road Congress, IRC. He's a member of Technical Textile Committee for the BIS, also an active member of TC218 ISSMG. He's a life member of IRC, Indian Society, IG. He has published numerous research papers in various international journals and conferences, and also associated with various prestigious engineering institutes as an adjunct faculty. Thank you, Sushant.
Thank you, sir, for your words. Now I would like to call Professor Dr. Mahajan, sir, to take the stage. The stage is yours, sir.
So thank you, Sushant and Professor. First, I would like to thank student chapter, the Indian Geotechnical Society, Roorkee student chapter, for giving this opportunity. Of course, thanks are due to Department of Civil Engineering, IIT Roorkee, which is giving an opportunity to share the whatever we know with the audience. Let me share my screen. Okay. Can anybody confirm you are able to see the screen?
Yes, sir, we can see your screen, sir.
Okay. Thank you.
Yes,
and
sir.
I would, and certainly I would like to visit Roorkee in person, probably next time soon, and I will maybe make a plan and inform so that we can meet face to face. But of course, we have learned through this COVID times, we can really be connected online as well. So let me start my webinar. So today I am going to talk about rockfall debris flow mitigation measures. Very specifically, I chose this topic because I felt this is the area which is very much relevant. Because when I look at the industry, maybe a decade back, when I'm talking of specifically of rockfall and debris flow, the industry, the response in India for these solutions was a little different. But nowadays, the acceptance levels is going up, and I think this is an area you must really enjoy working on it. Tentatively, I will take 30 to 40 minutes during this presentation. Basically, people and assets, what we are looking are basically exposed and vulnerable for natural hazards. In an interconnected world, losses incurred from natural disasters affect individuals and critical public infrastructure. An ecosystem on which individuals and firms depend, as well as the broader economic and increasingly complex environment in which the public and private sectors operate. When facing geohazard problem, we deal with risk. The risk can be defined as a product of hazard by exposure by vulnerability. They are defined as like hazard, the probability that natural phenomena such as rockfall or debris flow of a certain intensity occur in a certain period of time in a given area. Exposure or exposed value is the number of units of which risk element present in a given area such as human lives or settlements. Vulnerability, of course, vulnerability of an element, whether it is building, people, infrastructure, is an propensity to suffer damage as a result of the stresses induced by an event of a certain intensity. Let's look at the key aspects and approach for rockfall mitigation. The most common scenario for applying rockfall solution can be like this, where you have very steep slopes up to nearly vertical, then you have a relatively flatter, and then at the end a very flat portion. One possible solution in very steep slope could be a cortical strengthening. Of course, you have a transit zone where the falling rocks will be transiting, and then you have an impact zone, which is the place that must be protected from rockfall events, which may contain the properties, infrastructure, houses, roads, railways, anything, The approach to rockfall mitigation is based on risk assessment and risk treatment. It starts with characterization of instabilities, risk analysis, that is basically level, probability, and consequences, its evaluation, and then moving onward to identification of treatment options, implementation of risk treatment, and then monitoring and review performances. In terms of rockfall mitigation measures, we can divide them in three categories. Active solutions, these are the solutions where they reduce the likelihood of rocks from moving out of place. Basically, it reduces the possible deterioration as well. Second is passive solutions. It prevents the rock material which has moved out of its place on a slope from reaching the vulnerable areas. And of course, monitoring alert system. This helps when the movements are going to occur, that hazardous failure had occurred, or further failures may be imminent, is being informed. Obviously, active solutions are installed in the detachment zone, and passive solutions are installed in a transit zone, which are quite above than the last zone. So let's look at the solutions. What could be the solutions for the rockfall mitigations? Let's look at the first system, that's mesh system. In the mesh system, typically referred as a netting also, it is with nails and without nails. So when you combine with nails, it can be with rock slope or soil slope. Of course, when it is with rock slope, we call it as a secured drapery system. When you have a soil slope, basically soil nailing with a flexible system is an option. Without nails, of course, is a rock slope where simple drapery system is being installed. Now, this simple drapery system is installed when the rock surface is naturally unstable with an frequent small to medium sized rockfalls. Debris mesh is used to keep the debris contained and directed downward in a controlled manner. When you want a lightweight stabilization method, drapery mesh provides a flexible solution that conforms to the slope, requiring less heavy equipment or construction compared to more rigid methods. A trench, like here at the bottom, you will require to contain the fallen rocks where the open toe is applied. Here is an example of a simple drapery system where the mesh is draped on the slope and any falling rocks will be contained at the toe. Secured drapery, this is an example of secured drapery or pin drapery where mesh is more advanced slope stabilization technique compared to simple drapery. It is used when a higher level of stability is required, especially when there are concern about large or more deeply seated rock movements. The pins or anchors provide additional stability. to hold both mesh and the unstable rock face in the slope. On slope with uneven surfaces, irregularities, or ledges, the mesh may need to be pinned to the rock face to ensure close contact and prevent larger rock blocks from dislodging. The pinned system helps the mesh conform more tightly to the surface, reducing the chances of rock breaking loose and rolling under the mesh. Whereas simple drapery mesh passively manages falling debris, pinned mesh actively holds the potentially unstable sections of the rock face. So here, secure drapery is basically your actively holds the system, and simple drapery is basically passively holds the rock mouth. This is an example of a secure drapery mesh where you can see a cut slope basically is being made for construction of a road, and you can see the white dots that are nothing but the nails that's or the anchor that's being installed, and the black color what you see is a black color mesh that's being installed, which is a composite mesh of a steel wire rope and synthetic mats. Of course, one of the question will come, design tools and how to design this. Are there any design tools? So you can see a snapshot of the in-house software that have been developed over many years of research to meet the design and analysis requirement of Rockfall drapery system. The software is very useful tool that can help the designer to find out the most suitable solutions. And I want to share the good news with the students, the faculty, as well as the practitioners. This software is freely available online. Okay. In the next slide, I am going to show you the QR code. You can scan it and you can access it. Of course, I am going to provide the copy of the presentation, so you will have an access to that online URL also, or as well as the QR code. But the advantage of this online software is you don't need to install in your desktop or laptop or mobile phone. You just go there and then log in and you run the program there, and you have the projects and the results stored there and there itself. Similarly, soil nailing with facing design, that is Maccaferri design, is a new software to design the type of mesh in loose soil applications. Of course, if I have to cover the design aspects for this, it will take a very long time, more than let's say 5-6 hours, but in 30-40 minutes, I can give you the glimpse of it. So you can use Maccaferri design when you design a flexible system. You can scan this QR code, but just to give an idea about the, let me zoom the slide. Yeah. Here edesign.maccaferri.com, you can just type this in your browser. It is easy to remember, maccaferri.com and edesign. If you type this, you will go to the website and then you can access this software. This has been a dedicated software for soil nailing design. Again, it is available online. Now the portfolio, basically, let's look at the whatever we have mentioned previously, entire range of meshes being incorporated. But of course, when you design, the mesh is dependent on performance parameters of the products, materials that incorporate. It is very essential that products are selected with adequate performance, having long-term performance and durability, and which are tested comprehensively based on national and international standards. So the second photograph, what you see is a tensile test in progress. The last photograph is the punch resistance, where if you apply a force on this mesh, there will be a deformation. I think I can hear some background noise. Probably we may take some questions at the end. I will request everyone to be on mute so that the participants can hear. And of course, the extreme left photograph you can see is a mesh which is being exposed to the environmental condition and deteriorated due to corrosion. So all these parameters need to be considered. Of course, for understanding this, here are listed main international national standards for product performances and assessment. As I said, it will take a lot of time to go through this. I will provide the copy of this. You can go through these standards and you will understand the performance parameters. Of course, when we look at these standards, there are some requirements like certifications. When you don't have a standard at European level, construction product is covered by an harmonized standard basically European Assessment Document, EAD, is a public document and can be downloaded from EOTA, that is European Organization of Technical Assessment. So those who are interested to know about this technical assessment and part of design also, in the further slides I will be talking of this EOT and EAD. You can note down the numbers and they are easily available online. The EAD is used by a notified body to perform certification activities and write the European technical approval of the product. Only notified body is allowed to perform certification activities, and notified bodies themselves are certified by an accreditation body to be authorized for conducting these certification tests. The notification of notified body is issued by a national accreditation body, which is confirmed to the notified body as competence to perform product assessment according to the relevant standard EAD. When the CE mark is applied to a product, it indicates the product complies with the ETA and meets the declared performances requirements, and the quality management system, including factory production control, is in place and functioning properly. So whatever performances we talk, that has to be ensured. We must have these certifications. So for mesh systems, there are 3 EADs. EADs you can see here, that is 23008, 106, 05, and 04. These are related to DT mesh reinforced with the wire ropes or wire rope net panels or the wire ring mesh panels. We will see what these different products, how they look like. So here, this is basically the double twisted mesh with the steel ropes. In the context of debris system, we can see here 2 types of products, that is basically double twisted mesh with the steel wire ropes interwoven longitudinally into netting body called as a steel grid, and Mac armor where the steel cables are interwoven both longitudinally and transversely into the netting body. The presence of a steel wire ropes woven within the mesh during manufacturing enables better stress distribution in the upper longitudinal cables and reduce strain in the drapery system. Steel grid and Mac armor are ideal for use on high rock faces, slopes with long rock, or where large volume of debris are expected. The integral longitudinal steel ropes cables the efficient transmission of the loads to the top ropes and anchors within minimal mesh deformations. According to the EAD, the main mechanical performance characteristics of the products are related to the tensile resistance, that is tensile strength, and punch resistance, that is punching resistance, and also so resulting in the stiffness of each product. These performance parameters are critical for evaluating structural integrity of the drapery system. So overall, if you use the steel grid, you have punch resistance up to 195 kilonewton. If you use Mac armor, punch resistance up to 280 kilonewton. And tensile strength can range from 170 kilonewton to 255 kilonewton per meter. So according to site condition, these products can be chosen. Of course, then we move from the meshes of double twist mesh to the mechanical characteristics of HEA panels and ring panels, whereas HEA panels are stiffest product within the mesh range, offering the extreme strength at low strain. The panels are woven from a single continuous length of a high tensile strength wire rope, joined at each crossing point with a double knot connection. The ring nets have a highest strength of any mesh or system range with a high strain performance. Ring nets are ideal situations where very high risk of dynamic impacts. So typically, when you have barriers, you may use the ring nets. The nets are also used to face the rock slope featuring the large rock masses into the field, prone to failure. The ring nets can sustain high local stresses without any damage. Of course, when exposed to aggressive environmental conditions, a rockfall protection can quickly deteriorate, threatening the security of the people and asset. And you can see how aggressively it can be deteriorated. So this is a mesh without having proper metallic coating or polymeric coating. Here a wire rope with not having enough metallic coating, whereas you can see the other mesh with a proper coating. So of course, one of the ways to protect these meshes from the corrosion is providing the metallic coating. The metallic coating could be zinc or zinc aluminum. Basically, you have steel wire, and on top of that, you provide this metallic coating. Now, how exactly we can look at this metallic coatings and look at the life? Because one of the common question is how do you work out the life of these solutions? Of course, it depends on the Environmental condition, so low aggressiveness basically in rural areas or small towns around 100 meters above sea level, dry or cold zone, where atmospheric environment with short wetness, and desert or subtropic areas where you can have different types of coatings. Or medium aggressive is basically where you have atmospheric environment with medium pollution, some effects of chlorides, urban areas or coastal areas with low deposition of chlorides, subtropical or tropical zones. And high aggressive is where the atmospheric environment with high pollution, substantial effect of chlorides, polluted urban areas, industrial areas, or coastal areas without salts, spray of salt water, exposure to strong effects of de-icing salts, or maybe tropical, subtropical, industrial areas and coastal areas. So of course you can look ISO 17745, 17746, or even Indian standard IS 16014. It gives an idea of this. We call it as a site environment level, because based on the site environment level, you can estimate the life, or let's say estimated working life of the product. To make it simpler, let's look at the this low aggressive, medium aggressive, and high aggressive environment with a different metallic coatings. So maybe a zinc coating in low aggressive environment can last up to 25 years, whereas the Galmax C2, C3, which are aluminum alloys, zinc aluminum alloys, can last up to 120 years. Whereas very high aggressive environment, the zinc will not last much, whereas these aluminum alloys may last up to 25 years. Now, when we look at this zinc or zinc aluminum alloys, the difference in the cost compared to zinc is marginal or minimal, whereas the working life increases drastically, is around 5% increase in the cost. There is a five times working life is being increased. So 20 years to 125 years, that's what you can definitely or look into the increase in the life if you choose a proper metallic coating. Of course, this will result in less maintenance, less environmental burden, and of course less risk. In addition to that, polymeric coating, that's we call it as a polymac, has been developed. This new polymer compound extruded on a steel wire, it provides outstanding abrasion resistance. It performs particularly well against the mechanical and chemical impact. So if you are able to provide a polymeric coating on the steel products, then the durability goes quite high. And these polymeric coatings are tested for extreme temperatures, both with high exposure in terms of UV radiation, or let's say high abrasion, and extensive tests have been carried out on this polymeric coating. Now coming to the examples of meshes, that's what we have discussed about different meshes. So I want to show some case studies where you will get an idea. So this is a project for a hydropower project where the protection of the portal has been done with the help of the HEA panels and DT mesh. This is basically Vishnugad Pipalkoti hydroelectric power project. This is a secured drapery. Secured drapery means combinations of the anchors and the meshes. Then the next case is about landslide mitigation. This is in Uttarakhand. On the left side, you can see the site condition, and then on the right side, the installation of these panels, that is HEA panels and the DT mesh, a combination of this. So of course, here again, the purpose of the meshes is basically to contain the rock masses which may get detached. This is a project in basically east part of the country, Nalabari, Assam. This was basically rockfall protection works along the railway line Dudnoi-Mendipetar. Here the client was NFR, Northeast Frontier Railway, and we were the contractors. Here high energy absorption panels and steel grid was being installed with top and bottom and surface anchorings. This project involved construction of a BG line, basically which is around 19.4 kilometers from Golpara district in Assam to West Garo Hills in districts of Meghalaya. In this around the area of northeast, basically NFR operations is characterized by exceptional beauty and same time by some most arduous terrain. This difficult terrain limits rail network. Here, with view of improving the passenger amenities, NFR decided to construct this BG line, and you can see The hill was cut vertical, and the rock was a lot of fractures and joints, where the side slopes is almost vertical. Space availability is very challenging one. During the construction of the track, large quantities of rock cuttings and blastings were done. Because of these activities, the rock above the slope have become unstable, and there are possibilities of rock fall. That's where the mesh have been draped and the secure drapery system has been there. Now moving to the next mitigation measure, that's the rockfall barrier. Rockfall barriers are basically systems which have intersection structures. This is typically a mesh. Then it has supporting structures, typically are referred as a steel post. And then you have the connections typically, or the accessories, which are the rope, shackles, clamps, or the energy dissipator devices. So many times it is very difficult to have a drapery system because of the very high slopes. You cannot drape the whole slope. The alternative is to provide the barriers. The barriers are very cost effective. For design of rockfall barriers, you need to model the sections of the slope where you can have simulation of the rock fragments getting detached, and these are simulated, and then you choose the location of rockfall barrier, which will basically catch most of the falling rocks, so the height capacity will be decided based on the location of the barrier. Of course, the choice of barrier has to be tested and approved barrier. There are again different standards, which are design standards and the product standards. For India, you can refer IRC HRB 23, that's the special report, which covers the the design part of these barriers. You can refer IRC SP 48 Hill Road Manual, which basically gives the product characteristics. And of course, related to product, earlier ETAG 027 was there, which is now superseded by the EADs. Now, in European assessment document EAD, this covers the rockfall barriers. In this, of course, the components of the products are covered, the lifespan, durability, the methodology of full-scale test. That's basically we refer as a crash test. So I will show you one crash test, how exactly the barrier is being tested. The main characteristics of the kit, that is essential characteristics, are being defined in this EAD, and of course the production control. Now these energy barriers are defined by maximum energy levels. The maximum energy level is basically the highest level of energy to which the barrier can withstand. The MEL test is considered to be passed if the barrier stops the block, or the block has not touched the ground before barrier has reached its maximum elongation. So elongation, energy, these are the two parameters from this slide we can understand. Another parameter is residual height. So when you have a rockfall barrier being installed, it has a certain height, So let's say you have a rock which is coming down and it hits the barrier mesh. So the barrier mesh will elongate and you will have some deformations. Because of that, you will lose some height. So let's say original height was HN, and after the impact you have the residual height as HR, So the barrier height, residual height, let's say 75% of the impact or 50% after the impact. This basically classifies the barriers of class A, class B, depending on the residual height. Now I want to just demonstrate how the crash test is being carried out and how exactly we basically qualify the energy capacity of the barrier and the elongation and the residual height. So you are going to see a demonstration of the crash test. So I will just play again. So the requirement of the crash test is you need to have at least 3 spans of the barrier. You have the post. You are going to have the upslope cables with the energy dissipating devices, and then the mass or weight of the block, which is dropped from a certain height. So the energy, how much it will be at this point, and then The barrier shall effectively stop this falling rock and contain it without the rupture. Okay. Now these barriers are defined based on the ME level, as well as there is a service energy level also. Now, when we look at these barriers, there are again different capacities: low energy barriers, high energy barriers. Up to 75 kilojoule, we typically, or below 100 kilojoule, are referred as the low energy barriers, and higher energy barriers presently are available up to 9,000 kilojoule. That's the widest range of rockfall barriers that are available. Let's look at some of the cases where these barriers are installed in India. This is the Mumbai-Pune Expressway. So this project has been completed, let's say recently, where you can see the rockfall barrier that's being installed here. Here, there are possibilities of the detachment of the rock mass from the fill, where the rock mass can basically roll down, and then because of that, let's say you have a rock mass coming down and it will be caught here, and you can see it is very close to the highway itself. So the elongation, because after the impact, the elongation of the barrier shall not be too high, so that any trucks moving here shall not get obstructed. So elongation is very important part. Residual height, let's say this is the initial height of the barrier. After the impact, it may reduce this much. If you have very low residual height, the possibilities of the rock mass bouncing will be there. So here you can see the barrier being installed for the Mumbai-Pune Expressway. This is another location. I am getting my own voice. Is the same with everyone? Now here you can see the rockfall barrier which is being installed near Adoshi Tunnel. You can see these are the posts I can highlight here, and this is the interception mesh. Again here you can see there is a vertical cut, and this is a tunnel where you have the Mumbai-Pune Expressway. And unfortunately, around a decade back, at this location there was a rockfall where one casualty was recorded. After installation of this barrier and mesh, till now the route is safe. This is another project in Himachal Pradesh, where you can see the rockfall barrier is being installed. These are the ring nets. You can see the rings here. This is the post. These are the upslope anchors, and this portion which is shining here are the brakes, energy dissipators. Basically, how rockfall barriers works is the mesh deforms as well as the brakes deform, and that's how they absorb the energy. This is a project in Uttarakhand on the Badrinath highway. This location is Goltir. Again, here you can see the installation of rockfall barrier. This was around 1500 kilojoule barrier, which is being installed. The mesh here, you can see the ring net, and then you have a double twisted hexagonal wire mesh. Let me just zoom for you so you get an idea. Yeah, you can see the ring net. This is made of steel wires, and then you have double twisted hexagonal wire mesh. Again, it is made of steel wires. This is the post, and these are the upslope cables. This is another installation of a rockfall barrier in Uttarakhand. You can see here, this is a vertical cliff, which is a possibility of rolling of a rock mass, and this is getting contained here itself. Of course, the location of the rockfall barrier is decided based on the trajectory of the falling rock mass, and then the height is also accordingly decided. Here, around 3000 kilojoule barrier was installed. There's another project, Apara. This was for the ECR railways. You can see the installation of the barrier here and the drapery mesh, a combination of the square meshes and double twisted hexagonal mesh. This was around 1500 kilojoule barrier. This is for an hydroelectric power project in Uttarakhand. Installation of a barrier around 3000 kilojoule. You can see again the barrier with the different components that is being installed. This is on the northeast part of the country, Sevak Rangpur Railway Project, Riyangad. This was a temporary rockfall barrier. So you can see here the highway, and then on the hillside there was a construction of a railway line going on to contain any rock mass which will come down. A temporary rockfall barrier was being installed. This is one of the oldest project which involved the installation of a barrier on a vertical cliff. This is a project in Maharashtra, Saptashringi God Temple. This is around 150-meter long barrier. I will just zoom for you so that you can see the slide. Yeah, you can see here barrier being installed. In this project, the first time the helicopter was used for installation of barrier itself. So installation of this rockfall solutions is really challenging. Even installation of meshes here were not done using the conventional labor or construction crew, because reaching this point for installation of meshes was challenged. Here, the expert rock climbers, the trekkers were being hired for reaching on the top and then spreading of the meshes. So again, very customized solutions and the installation support sometimes is required. Here, moving to the next portfolio. So first we have seen meshes, second the barriers, the third is the rockfall embankment. So again, the rockfall embankment design methodology is based on the trajectory analysis. So you need to model the slope, and then you do the modeling of the falling of rock, and then accordingly you design the sizing of the embankment which shall be able to contain the rock mass. Of course, the global analysis, internal stability analysis of the rockfall embankments are done with our in-house software. That's the MaxStars. Here, the solutions could be a gabion wall or a reinforced soil structure with TerraMesh system or TerraMesh green or Paramesh. Until recently, the dimensions of the footprint of these embankments have been limited by geotechnical parameters of material used to construct the embankment. With over 30 years of experience in geosynthetic reinforcement, we have developed significant expertise in use of soil reinforcement using Maccaferri soil reinforcement solutions to construct rockfall embankments. These have numerous advantages, like footprint of the embankment is dramatically reduced, steep slope angles is possible, embankments is more stable and robust, and site-owned materials can often be reinforced and reused, embracing the sustainability. We manufacture a wide range of soil reinforcement. Of course, in situations where extensive natural hazards are expected, embankments can offer cost-effective solutions. Basically, rupees per kilojoule capacity. Cost is very effective. Almost very high capacity. You have seen barriers up to 9,000 kilojoule or even sometimes 10,000 kilojoule. But the embankments can have the capacity more than 20,000 kilojoule. So this can sustain the multiple impacts without repair, contain vast quantities of debris, and easiest to maintain. So this is very, very cost effective and very effective solution. So these are the examples. So you can see here, this is a reinforced soil embankment with a vertical faces that's being built. That's an embankment where you require some space for construction of this embankment. So you can see during the installation work and the view. Or you can have a steep slope, 70-degree slope, which is built using the green TerraMesh, where you can have even the vegetation. And this is the photograph. You can see the size of rock mass the same embankment has contained. This is a project in Italy. You can see very huge rock mass being contained, and this is coming from a hillside. So very high energy which can be contained. This is a project in India. This is in Uttarakhand. The project called as Lamgad. Actually, the project was a widening of the highway and basically protection of the road from the rockfall events. So you can see here construction of a reinforced soil structure that's being done so that any rock mass which is rolling down from the hillside can be contained, and you can see here already some portion has been contained. So I want to show one video, where this is a live falling off or sliding off a rock mass and the rock boulder, I will not say boulder, but huge rock mass was being captured. Thanks to the person who was present at site and who could take this video. This embankment is approximately 10-meter high. You can see, this is usually the phenomena. First, the fine particles will be moving, detachment of the rock mass will be initiated, small rock masses, and then huge rock mass. This rock mass, if I estimate, probably this is almost more than a size of a truck, which has rolled down, but the embankment could contain it. The Rockfall embankment could contain it. If this embankment wasn't there, the whole mass would have been accumulated on the road. And this road is access to the Badrinath, and lakhs of pilgrims every year use this road. With the installation of this embankment, of course, it's very safe now. Of course, very important point I want to mention: in Rockfall protection works, you need to take care of the maintenance. The maintenance is, of course, after this event, you have to go down here and clear the debris so that you maintain the space for collection of the further debris in future. Moving on, the next hazard, that's the debris flow. A debris flow is a fast moving, composed of water, saturated mix of soil, rock, organic material, causing significant damage as it rapidly descends. Debris flow can be triggered by intense rainfall or melting of snow or volcanic activity or earthquakes or deforestation. These events saturate and destabilize the rock mass, causing flow downhill. Of course, this debris flow can be looked into the three zones, that is triggering zone, transit zone, and runoff zone. The triggering zone is the area where you have steep slopes, you have loose soil, little vegetation, and of course, this is typically characterized by the very steep slope, an area often very high gradient where water can rapidly accumulate and saturate the soil, making it more prone to sliding. The presence of previous landslide, bare rock, or volcanic ash can also be contribute to the likelihood of the debris flow. Additionally, the trigger area might have a convex or concave shape that funnels water and debris flow into concentrate by increasing the flow's initiation potential. The transit area of debris flow is a zone through which the flows moves downhill after being triggered. This area is typically characterized by a channel such as gully or ravine or riverbed that guides the movement of debris flow. So just to give an example, if you remember 2013 tragedy in Uttarakhand, it was mix of floods and debris flow, and you can imagine what kind of damage it can do. It can erode channels, picking up the additional materials, increasing the volume. Even the landscape itself gets changed because of the debris flow. The transit area is crucial, determining the final impact zone of debris that dictates the path and spread of the moving material. The runoff zone, also known as the deposition or runout zone, is the final area where debris flow loses its momentum and deposits the carried material. This zone is typically located at the base of the slope, often flatter area. This area can be experience significant accumulation of debris, leading to the transformation of new landforms and altering the existing ones. The extent of runoff can vary depending on the volume and speed of the debris flow, as well as the topography of the terrain. Of course, when we look at the transit zone, here we need to look at for controlling the flow, reduction of water speed, or control of the erosion capacity and transportation of the debris. Here you can see a different types of solutions which can be applied in the runoff zone. Can be embankment, can be a barrier, or check dams. Today we are going to talk of a debris flow barrier, which is nothing but a structure designed to intercept, slow down rapid flow of water and preventing it from reaching the vulnerable areas. The debris flow typically would look like something like ring nets with the cables and the energy dissipating devices. The design of debris flow barrier is basically a mix of geological and hydrological characterization of basin where the debris flows are required. Obviously, in debris flow, you will have certain volume which is very common, ordinary, and sometimes you have very peak flow. So the design approach is basically letting the ordinary flow. So you allow the ordinary flow to pass through. So you put the barrier with certain gap between the river bed or the channel bed and the barrier, so that the ordinary flow can pass through, whereas the peak flow is being contained, which will include the solid transport, So for design approach, first you need to know the channel geometry, and then accordingly the dimensions of the barriers to be checked, and of course the dimensions of the barriers shall be certified. Second step would be the volume. Single or multiple barriers will be needed based on the estimation of volume, how much volume one barrier can accumulate. And of course, depending on the debris density, debris flow speed, and debris the flow height, the barrier design pressure, can be determined. Here again, we take the help of the certified C barriers as per the European technical approval. The European technical approval EAD 340020000016. This defines the two group of products: debris flow barrier and shallow landslide barrier. This document defines the methodology to conduct the full-scale test for each group and defines the methodologies to assess the product performance. Of course, the performance of the products will be determined based on how much pressure it can withstand, how much flow it can be accumulated. So here, the option one is you do a full-scale test on a single product, and then you go ahead for the ETA approval and CE marking. Whereas option two is you do the two tests which are calibrated, and then you calibrate a numerical model, and based on that performance you go for ETA approval and the CE marking. Now, if you have to understand the components of these flexible debris flow barrier, it has the panels to cables connections. So you have ring panels, abrasion plate on the top, because when you have debris flow, possibly the extra flow will move over this, and then your cables may get abraded. So you put steel plates or that takes care of the sacrificial nature. Then upper cables connections, intermediate cable connections, and lower cable connections. According to EAD, these flexible kits for retaining debris flow and shallow landslide, or the calculation method is you allow the, as I said, ordinary flow, but when you have a debris flow coming, you have an impact pressure where the first impact of the debris will come, and then it starts filling up, and then you have an overflow. So you need to take care of the pressures coming from impact, filling, and overflow load. Now these debris flow barriers, we have the two types. One is narrow channel and wide channels. So narrow channels is up to channels up to 15 meter top width, and then wide channels up to 25 meter top width. So for narrow channels, 65 to 165 kPa pressure barriers are available, whereas in case of the wide channel, 65 to 185 kPa barriers are available. When we look at this debris flow risk assessment, we provide the expertise in analysis, hazard evaluation, and implementing tailored solutions. Of course, here you need to understand what is the catchment area, how much rainfall it can occur, and then how much is the volume that will come. And then for designing the protection system, creating the customized solutions that ensure the effective mitigation of debris flow, taking into account site-specific requirement. If required, the numerical models are run to check the pressures coming on the barrier, the forces coming on the cables, post, and the anchors. Very important part of any civil engineering structure, no matter how effectively you are designed, you need to have the installation support. So being specialized structures providing installation support. So we provide installation support, which are basically site-specific challenges, optimizing the performance and debris flow mitigation. What we talked of all these, from whether it is a meshes, whether it is embankments, the barriers, rockfall barriers, or debris flow barrier, please keep in mind, very important part is the performances, and these performances need to be certified according to ETA, EAD, and very important, whether the installation is completely as per the satisfaction of the designer, where we can help in providing the site assistance for correct installation of these products. So as I said, installation is very, very important. Now, very important part, may it be the mesh, may it be the rockfall barrier or the debris flow barrier. After installation, these structures are installed at remote areas where you don't have access and you don't have a watch. So these rockfall and debris flow barriers are essential to safeguard against nature's unpredictability and standing resilience against boulders and landslide. Here, with HaloMac Geo, which is an alert system, these barriers become smart system and they gain the comprehensive monitoring capabilities. With 8 sensors meticulously positioned and supported with 8 legs, the HaloMac Geo covers the every panel of the barrier, instantly detecting impacts and triggering real-time alerts. A robust construction enables it withstand harsh conditions, enable reliable performance in the most remote locations. Moreover, its ability to cover both GSM and satellite. It means these sensors or the HaloMac Geo system will work on the mobile phone signals in case you are in a remote area, you don't have mobile phone coverage, then it works with the satellite network. So this guarantees uninterrupted connectivity. You never go out of the coverage. This is very crucial for remote monitoring. The comprehensive coverage combined with HaloMac Geo, other feature make is cornerstone of the safety and lives and infrastructure. Safety for lives and infrastructure. With this, I would like to conclude my presentation. Thank you for attention, and I think I'll be more than happy to answer your questions. I will try my best to answer your questions.
Thank you, sir, for your lecture. Now we will take a few questions. One question is from Dhruvil. How to approach any problematic site which is susceptible to land debris flow or rockfall frequently?
Thank you very much for the very important and basic question. Of course, when we look at this problematic site, let's say susceptible for debris flow frequently, that means we know there has been a debris flow happening. So here, the common saying which is garbage in, garbage out. What it means, you need to have a quality input data. The quality input data would be like understanding the catchment area from where you are going to have this debris flow initiation, why this debris flow is getting initiated, then estimating the volume. After you estimate the volumes of this debris flow, then identifying the location where the debris flow barrier has to be installed. Of course, it has to be little away from the area which we want to protect. Okay. After understanding the volume, we can again determine whether one barrier would be enough, because you know the channel geometry, you know the barrier height, you can calculate the volume. So if that volume is lesser than the volume expected from the debris flow, then we may go for multiple debris flow barrier. Of course, we can allow some overflow. The purpose of these barriers also will be to reducing the velocity and the impact. And then accordingly, you need to understand even the geology and geotechnical aspects of the site. So one is hydrological aspect, another is geological and geotechnical, where we will need to put these cables through anchors. So to design the anchors, we will need to understand the type of strata, and then accordingly the anchors can be designed. This is how basically you can approach. Of course, one of the important parameter here, we need to understand the rainfall pattern and the expected rainfalls in this area, and then approach this debris flow barrier solution.
Thank you, sir. The next question is from Krishna. Along the highway of Mumbai-Pune, how you decided the location of these barriers? Any software used for this or just by the physical survey?
Thank you very much, Krishna, for very relevant question, because this is the $1 million question. Where do you put the barrier? No, that's the very important aspect. So for this, as I have explained in my presentation, first you will need a topographic survey from where you will understand the cross section. Once you have the cross section, then you need to understand the type of material on the slope, whether it is a loose material, whether you have vegetation, whether you have rocky surface. Because why you need all this to understand? Because you have a rock which is getting detached, now it will roll down. If you have very good rocky surface, the bounce height will be very high. If you have a loose debris, then you have less bounce height. That we call it as a coefficient of restitution, which we study in your engineering, So coefficient of restitution will govern your how it bounces, it rolls down, if you have vegetation. So all these are studied, collected the data, model the surface. Now this surface is modeled in a software called Rockfall. That's from the rock science. You can get this software and then you model. Now important part is the volume or the size of the rock which will get detached. How do you determine? Again, we are engineers, we need to solve the problems which are not really predictable, because you don't know how much rock mass will come down. Can you predict? No. So then what is the solution? So for that, any past incident which has occurred, then you need to have the data, how much big rock mass has come down in the past. Note down that observation. Secondly, geological study of the area, where we need to understand the rock joints, the dipping of the rocks, and from there we will understand the probable mass which will come down. So once we know the mass, we know the profile, and then you start modeling. Then you have the trajectory of falling of the rock, and then you decide the location such a way with the minimum height of the barrier you are able to contain maximum trajectories. That's where the location of the barrier is decided. Of course, it is to be decided such a way, if let's say example of Mumbai Pune Expressway that's being asked, you have a road and then you have, let's say, trucks which are flying there. So the barrier, if the deformation of the barrier, let's say, is 3 meters, so that means you need to have a barrier little away. Let's say if the barrier is going to deform 3 meters, then at least you put it 5 to 6 meters away from the road surface, so that even if the rockfall is happening, the deformed shape of the barrier is not obstructing your movement of the vehicles. So one, containing all the falling trajectories. Second, sufficient margin for the infrastructure which you want to protect. This is how exactly you decide the location of the barrier. And of course, for that you need to have detailed geotechnical, geological study, and of course you use a software.
Thank you, sir. The next question is from Pratik Goyal. Can you please tell what are the new sensors technologies that are going to be used in the near future to mitigate these issues?
Yeah, so it's very interesting question. Of course, we are talking of a future. So let me start with the state of art, what's available, and probably what could be the future. So state of art, what's available is sensors, which basically are two types. One is a sensor which monitor the structure around the clock, 24/7, and in that sensors you have a lot of data coming from sensors, and then it is transferred to a location. It could be a server or a cloud. So you have millions and millions of records. Okay, now that millions of records may be useful for you if you put a site specific program and then you train that program to give an alert. That's the typical monitoring which is being adopted in geotechnical engineering. But the another approach what we have adopted is an alert based system. What is alert based system is, it doesn't capture the data like every second or every minute, but you have a sensor, it is live there. Okay, when you have a known deformation, let's say, yeah, I want a sensor to be alerted for a deformation of, let's say, 1 centimeter. So I can calibrate that sensor and put it there. This sensor will communicate with its cloud once in a 24 hours, so that it says I am alive. The moment you have that 1 centimeter deformation, it gives an alert either through GSM network or through the satellite network. You can receive that alert on your mobile. You can receive alert on your email. Even you can configure that alert to, let's say, take an example of Mumbai Pune Expressway. If you want to put a sensor there, you can put a traffic signal, let's say 500 meters or 1 kilometer ahead of that barrier or a mesh or anything, whenever you have movement, you get a signal and alert, and it goes to the traffic light and it blinks a red light so that the whole traffic stops. That's one possibility. Or you can inform to the authorities and they take care of it. So this is present situation. Maybe future, I think with the looking at the future in terms of the artificial intelligence, probably we will have a lot of models which will come up, which will have the data coming from these sensors, which will be trained from the, let's say, the analytical and numerical models, and we will have some prediction that this is possible movement. It can have detachment, you can have landslide, or maybe a debris flow. For example, the Hellomac Geo, what I mentioned, you have debris flow occurred and then you have alert. But there are different systems which can predict. For example, one of the question the participant asked, what about the debris flow, how you access or how you approach? So for example, that in certain area you have a rainfall of 50 millimeter per hour, and when that shoots up to, let's say, 60 or 70 millimeter per hour, you have a debris flow occurring. Then you can have a rain gauge which is calibrated, which is with a sensor. The moment it crosses 50 millimeter per hour, immediately it sends a signal. This is a preemptive one. There is a possibility of debris flow and everything can be stopped. You inform the local people, you inform everyone. That kind of future possible sensors could be coming in the future.
Thank you, sir. Another question is from Anup Singh Chandel. How do you compute the bearing capacity for the debris flow, as the incoming flow pressure is mostly unknown?
Yeah, so the barrier capacity is determined based on the actual test. So what I mentioned in EAD, you have two options. One is you do a full scale test for each scenario, or you do a full scale test, maybe 2 or 3 for each variant, and then you do the numerical modeling simulation, and then basically the numerical model will be calibrated. So first you do the test and then you give it to numerical model. This is how it behaved in the field, and then you train your numerical model. It simulates exactly what happened in the past. Then your model is ready for any uncertain, let's say, scenarios of different channel boundaries or the flows. Now, when we know the debris flow, as I mentioned, there is impact pressure, then filling pressure, and then overflowing pressure. So these are the three pressures which we know. So with these three pressures, of course, it is governed by what is the velocity of the debris flow which is coming. How much amount of debris flow it's coming. So that's what I said in the beginning. Garbage in, garbage out philosophy. If you want to follow, you can take random numbers. I really thank the participant Anup Singh for asking this. Here, to compute the barrier capacity, you need to understand the amount of flow, the velocity of flow, which we need to predict, and then you determine the barrier capacity which is required for that particular site.
Thank you, sir. One question is from Mohammed Bilal. As shown in the figure, the debris flow barrier are located in the transport zone. So how is the debris cleared after the flow has happened?
Thank you very much, Bilal. As I said during my presentation, rockfall or debris flow solutions require maintenance. If someone says you put this and forget it, then it's a lie. All these solutions you will require maintenance. Now, in case of barrier, once you have a debris flow which has occurred, you know that it's occurred. The way to do the maintenance is, of course, you will have to do it by manually or by machine, excavate the material and transport it and dispose it safely. That's the way you will have to clear the debris.
Thank you, sir. Sir, one of my question is that, sir, what are the different design factors or parameters that you have to consider for the rockfall and debris for the mitigations? But key parameters.
Yeah. So, Sushan, your question is quite broad, but let me take for which one you would like to address: barrier or mesh or
It's a barrier, mainly the barrier where the rock is to fall on that.
Yeah. Okay. So for rockfall barrier, of course, what is the parameters or the input and design parameters you need to consider, right?
Yeah.
So for the rockfall barrier design, first we will have to understand the density of the rock mass, which is going to come down. The second, the volume of the rock mass, which is coming down. That's the input parameters. From what height, what trajectory it will follow. That's the parameter that we will need to understand. And then the part of design, you understand the trajectory, you know the energy which this rock mass is going to bring at a particular level. Now you can follow the limit state approach. Here you increase this energy by a certain factor of safety, which you can put as 1.1, 1.2 based on your accuracy of the data and the energy, whatever energy you have tested the barrier, because I have shown you the video how we are going to test the barrier. So you have the energy which is the barrier can take, and you reduce this energy by a factor. So you increase the driving force, that's the energy coming from the rolling mass, and reduce the resistance, that's of the barrier, and then you design the barrier for the project site.
Thank you, sir. There are lots of more questions. Would you like to, sir, answer, or we can?
We can take these questions over email. You can send me. I can send an answer to each of the every question, and you can send it to the participant. That way, an engagement of student chapter with the participant still will continue, not
Yeah,
remaining to just.
It was a very interesting lecture, and a very engaging lecture also. Lots of question was there, so it was a very interactive lecture.
Thank you.
Uh, uh, as we came to the end, I am very much thankful to our speaker, Dr. Ratnakar Mahajan, for giving his valuable time and showing the different mitigation measures for the rockfall and the debris flow. I am sure that this lecture has benefited many of us in understanding the real-life geotechnical challenges. Dr. Mahajan, we sincerely appreciate your time and effort in accepting our invitation and sharing valuable expertise with us. Thank you, sir, for giving us time. Now, I would like to everyone to please open your camera so that we can take a screenshot for the record.
Yeah, thank you very much. I again thank the student chapter and the Department of Civil Engineering, IIT Roorkee. I think I thank all the participants for taking out their time and giving me a listening ear.
Thank you, sir. We are very much thankful to you. Thank you. I am also thankful to all the participants for February. So till then, bye bye, and we will meet you again on 20th of February. Thank you. Thank you, sir. Hope
Thank you all.
soon.
Sure.
Thank you, sir.